Hello everyone. I hope you are doing good. In last sessions, we talked about ML.NET ecosystem for deep learning. That is next stage from classic machine learning. We are moving as an advanced topics now. So deep learning is advanced topic for ML.NET. Now we already talked very two sessions about the deep learning, what deep learning, how it differ from classic ML.NET, but in this session I will walk through you in transfer learning. This is another term, transfer learning in ML.NET. What is transfer learning? This question in your mind, yeah. Every day I'm coming with the new topics and probably you have confusion. Don't be confused. I will explain you step by step. Transfer learning is very important topics in machine learning and AI ecosystem. Transfer learning means if you have already built machine learning model, you need to use this model for your custom requirement. So what exactly you need? You are doing something, you are transferring. So pre-built model is available. Just utilize this model and fine tune on your custom data set. As you can see in this diagram, uh, the model is already trained with many dense neural convolutional neural layers, and then it's give me classification whether your image belongs to cat or your image belongs to dog. But it's not only cat and dog. That's the fundamental question to decide which class this image belongs to which class. But as an industry you can use this. So in the industry you belongs to manufacturing or you belongs to any industry, and if you are dealing with the image, then you can use image classification. Deep learning models are available here. ML.NET support various libraries. Those libraries are TensorFlow libraries are there, PyTorch is there. You can utilize those models. So here I'm explaining in this session ResNet V2 101 model, which is already trained on millions, around I think 10 millions or millions of images and thousands of classes. This model already trained, we will use this model as a transfer learning and fine tune it on our custom dataset. Let's have a look how this training will work and why we don't train model from scratch. That's also a fundamental concern. I think you should understand before dig it down into the transfer learning and deep learning concepts. Let's try to understand what happened. Let's assume if you are training, if you are building your own image data set, then in a world there is thousands lakhs of image categories. It's already available. You need to train your model for each category. That's time consuming, isn't it? So that's the reality. You can look at here. I prepared this for you guys, especially what is problem with building a deep learning model from scratch, that I especially prepared for you. Let's have a look. You need millions or billions of images. Your CPU is not enough. You need high quality GPUs. Your training time would be weeks, hours, months would be your training time. And the data labels, yes, you need large amount of data labeling, and this is time consuming activity because the labeling would be done on the manual. It's no automatic because you have to first define this image is what. If you remember, or if you try to recall, almost many times on the web there is a captcha, and if you, especially for the Google, and they ask you, hey, can you map the bicycles in the pictures? Hey, can you map all the motorcycles in the pictures? Can you map the buses in the picture? Can you map red lights, green lights? What is that? They are doing labeling. They are labeling their images. So this is called data labeling. So the image, as you pick, okay, this is the bicycle, this is the cycle, this is the red light, this is the bus. This means this is the labeling you are doing it. Yeah, this labeling you are doing for them on the free of cost. So that's the time consuming and cost. huge cost in the labeling. So that is the pain of machine deep learning models. That's why I prefer and I recommend utilize the power of transfer learning. If you are passionate, you have resources, hardware, images, you have money, most welcome. Go there and write your own model and start your own model from scratch. So let's look at here. You have a small data set. Your small data set is available here. Then you perform the image processing as a dense layer, as a last layer for fine tuning your model. Pre-trained model you already use it, so ImageNet, ResNet, these models we will use. And then feature vector is created based on my feature training, and then classify, yeah, a small neural network I prepared it, and then it is ready for your business classes. So the model will predict, hey, this belongs to this belongs to this. Or if you are in the manufacturing industry and you want that I would like to track whether my item is defective or not without any human involvement, you can use the image classification. It will detect the error in your product or the defects in your product and then classify based on the images. So it's called computer vision. The power of transfer learning is you need a small data set, you need a small custom data set. You don't need GPU, so your CPU is fine. Time is minutes, hours. Data labeling is small because you have your custom data set, could be hundred thousands of images. Yeah, risk is very low. Let's try to understand how this complete ecosystem will work. So let's have a look here. The model, the deep learning model ResNet is already trained on millions of images and thousands of image classes. So this bigger size of model already trained. You can see over here. This model is already trained. What we need, I don't need training this model from scratch. As simple as my last session, I explain you, if you are a .NET developer and you want to write a program in the C sharp, this means you will not start writing a C sharp language compiler by own. Yeah, you are utilizing it. So what are you doing? You are using transfer learning. So you're utilizing C sharp power and writing your own code. It's the same similar way we are utilizing the power of ResNet data set and then training on my custom data set. As simple. Yeah, here this is I'm using. And what you use, so you have your small data set. Now you have a small data set, and this is this, as it is you use it, is called frozen layer, because you don't need any provide any training on this data set. What you need a small custom data set and then add a fine-tuning layer on top of this. So this is a fine-tuning layer, you can see over here. And then your dataset is ready. Your dataset is ready and your custom model is ready. So with the less power, you can use that, isn't it? This is the magic. So you already utilizing transfer learning a lot in your career. You're using tools, Visual Studio, you're using SQL Server, but you're not building it. Yeah, you are using it and then building your own program, your custom program. That's the same power. I will explain you how can you use in the machine learning, in the deep learning model. So let's start practice with me. As you can see here, I already prepared a program. This time I changed my practice, guys. This is step by step. I also learning along with you. What practice I changed, because writing a program while I explaining to you, it's taking a time and the videos are lengthy. So I try to minimize the video length and so that you can understand in a better way. I prepared the program in advance and then explain you line by line so that your concept will be very clear. So this is deep learning image classification we use in this session. What exactly we are doing here? So I prepared a small data set. The small data set is called I have around about 60 or 70 images for dogs and 60 and 70 images for cat with a different category. You can see over here. And then we have images for dogs as well. Yeah. So these images I have, so I will train my model on this custom data set where I label it, hey, these images belongs to cat, these images belongs to dog. So now after training this ResNet, my custom model with the ResNet, and then if I offer the new image for dog, that's definitely not belongs to training, then it will predict which class this image belongs. Yeah, that's the power. So here what we use, so you use the two or three new namespaces vision, image analytics, and TensorFlow Redist. This is required for deep learning, so let's use those. And then class, as you know, this is the classification, so we are doing the classification for images. If you're new, please refer the previous video which I record for classification. So there are different video I already recorded it, so you can refer it, and you already know. Most welcome. Let's continue with me your practice. And here this is the input and then the image prediction. So the model will predict as a label and give me the score as well. And this method is used for loading the images from the disk. So we'll load the images, and then the real power start here. So what we are doing here, we first stage we are loading the images. That's pretty simple, as you already know, loading the CSV from your disk. So I'm loading the images from the disk. So this is the image folder path I given. And then the column, as you know, the machine learning model, you need numerical data set. Yeah. So the label is text string. So we need to convert it. So the label is map value to key. It will encode into the keys. And then the images load images as an image byte array. You need to load there. So that pipeline will load images in a byte array and then provide the classification, image classification trainer. So here I'm using image classification trainer is ResNet V2 101. That's a classification. ML.NET supports several trainers. You can look at here. If you can see that there are several trainers are provided. One by one we will cover the other trainers as well. So ResNet is good for high accuracy. That little high, it is consume. The model size of the model is higher. It's not a smaller model, but it's okay. It's around about, I think, 150 megabyte or around about 150 megabytes. So here what this trainer requires, this trainer needs some options. So feature columns, so what could be your feature column? You're already aware about the feature columns. You need to provide the feature column. Here I have a feature column, it's called import. Then the label column, as it's asking, hey, what is your label column? My label column is label key. And then our case is the model, which model you wanted to offer, or what model you want to use for your training. Epoch is the passes. In the deep learning we call epoch the passes, and how many passes you will use to provide the fine tune or to fine tune the model. And then batch size, how many images is basically you will consider in a one pass. And the learning rate, that's basically weights. So weights would be updated on each phase, each pass, and then weight would be added for our model. So weights are nothing, it's a labeling basically we use. And then the matrix callback, so every time that's the delegate, so it's a callback basically. Every time a training continued, and then it will give the result what exactly going on in the training. And validation set, that's I use a null because I'm not using caching, so it's basically for the caching. And then next stage, the conversion. Now what we're doing, so at the first stage, if you look at here, value to key, now we will convert it key to value, because I need predicted label. I can't understand 011 or 0110 because that's understood by computer, but as a human we need to have labeling, so I convert it again. And then at the last stage you use the fit. So this fit, now this pipelining will utilize, and then my data set will pass through all the ResNet layers, those called bottleneck or those called frozen layers. Let's have a look. And at the last, what I did, as usual, prediction, create prediction engine, and where you provide the image import, image prediction, and then model. And when we predict this, let's say this test, I have image, I don't know what exactly this image. Let's look at together. This image in the test folder is okay, image 4. Okay, let's see. All right, so let's do it together. Let's provide the training. This training usually takes time. This is the based on your data set. Training take time. This is based on your data set. what is dataset you have, what the size of your dataset. It probably take time, but no need to worry about it because that's completely based on my dataset. Let's continue. Let me pause the video for several minutes until this training is not finished. Once it's finished, I will come back. Okay, welcome back again. So this training is done, guys. You can look at here. All the images are utilized by our model. So this is not an error. This bottleneck computation, yes, because this is the frozen layers for ResNet, and my images are go through these all these layers. So and then at last is trained, and then you can see here this final training is performed, and then accuracy is calculated, and then based on my transfer learning, different transfer learning is utilized based on the data set here. Then accuracy is good now. So it starts from 83, 88, 83, 83, 90, 92, like that. Okay, let's look at here. So at this last, and the training is done. Once training is finished, what I need to do here, I have image. Let's see the prediction. This image is what? Okay, can you see here the model gives the prediction and say predicted category is cat and the score is 99. Means model is sure, then the image which you provide me is cat. Okay, can you see I didn't do anything here. Its image name is IMG. I especially hide this, and you can see over here. Yeah, so this is based on the training. You can see this image is especially, yeah, cat. Okay, and I did some trick. It's not simple like complete visible. There is some, drawing happened on the cat. So let's do this with other image as well and try to see. Okay, let me open and let me search this on the real network. Okay, let's have a look. Let's use cat images. Okay, maybe I will use this. Let's see, not bad. Save this image. I would say okay, fine. Save this image on desktop, maybe it's fine. All right, this is image, fine. Go to here and then paste this. All right, let's open our model. I would say images. Okay, you can see this images.jpg. Let's see what model predict this. Is this cat or is this dog? Let's see. It says cat. 99% model sure about. Let's use dog image. Dog images, and then also predict what is that. Okay, let's use this. Save images. Okay, go to where it is saved. Save image, and then say okay, that's not good, that's AVI. Let me use another one. Save image. This is also not good. Let's copy from here. Yeah, maybe try to see this. These are not exactly image, isn't it? No. Let's see. Okay, thank God. What is the states, guys? Hold on. Let's see this PNG images. It should not be AVI. Let's hold. Yeah, that's fine. I think we can say images. Okay, desktop images, and let me download this. Okay, copy, paste, and then let's run our program and let's see what prediction is. Is it JPG or PNG? It's JPG. Fine. Let's see. Dog. Can you see? So this is the image classification, guys. That's the real picture of image classification. So let's continue your practice here. In this next session, I will explain how we can use TensorFlow models. Now here what we used ML.NET model for ResNet or ImageNet. In next session we will use TensorFlow model, and then we'll also see how we can use ONNX in ML.NET. You train your custom model, deep learning model in a Python, and then you export as ONNX compatible and use this in ML.NET. So going forward, it's a very interesting sessions. I will show you one by one. Let's continue your practice. Thank you very much.